Now, amortization is simply a concept of loan. So when some of us, when you go for loan, some of us think that you pay the tenor, but we still owe. It's because of the concept of amortization. Because in amortization, interest attracts interest. Okay. So you go for a loan for 5,000 cedis, and they want to deduct a certain amount every month. So you finish paying the loan. So here, that is the concept of amortization. So how does a bank get to calculate installment payment on your loan? So when you go for a loan, you yourself, you can calculate it yourself. When you go for the loan, when you know the interest rate, when you know how long it will take you for you to pay the loan, you must be able to calculate it yourself. The monthly payment you must make, or the yearly payment you must, like, you can do it yourself. That's the concept of amortization. Now, anytime you pay an installment to reduce your loan, that installment or that fixed amount you pay every month or every year to reduce your loan obligation, that amount contains part of the principal and then the interest. Any amount you pay, it contains part of principal and what? Part of interest. All right. Okay. Now let's employ the concept of time value of money to learn amortization. Let's employ the concept of time value of money to learn amortization. So we are employing the concept of time value of money to learn amortization. Okay. We are employing the concept of time value of money to learn amortization. Okay. Now remember, present value of ordinary annuity is equal to what? The payment into bracket 1 minus 1 plus R raised to the power n all over R. Now, when you go for a loan, loan is a noun amount. Loan is a noun amount. Yeah, I always forget my negative n. I don't know why. Thank you again. Negative n. Thank you. Loan is a noun amount. Like, it's a noun amount. Noun amount. Loan is a noun amount. And we make a certain installment payment to clear the loan. Okay. So here we can say that the present value of the loan is so loan is equal to the payment into bracket 1 minus 1 plus R raised to the power minus n all over R. So when you divide both sides by this factor, it means the payment you must make to clear the loan is loan divided by 1 minus 1 plus R raised to the power minus n all over R. All over R. So if you want to know the installment you have to pay to clear a loan, this is the formula. If you want to know the installment you have to pay to clear a loan, this is the formula. So let's take an example. I'm waiting for some of you to write the formula down. So let's take an example soon. Suppose you have 1,000 cedis 3-year mortgage. So suppose you have 1,000 cedis 3-year mortgage with an interest rate of 10% and semi-annual installment payment. What are your semi-annual mortgage payments? All right. Now, listen to me carefully. Let me teach you from known to unknown. All right. So let's say you are paying its annual payment. Forget about semi-annual. Forget about the semi. We will resolve the question assuming semi-annual. But for now, let's assume it is annual. So I'll teach you something you know so that we bring it so that we can now come to semi. Because if I start with the semi, it will get some of you confused. So you are making annual a 3-year mortgage, but you are making what? Annual payment, all right? Annual payment. So the loan is 1,000. Now years is 3, interest rate is 10%, all right? So the loan, 1,000. Years, 3. Interest rate, 10%. So we want to know our installment payment, right? We want to know our installment payment. So we are saying that the installment is equal to the loan over one minus 1 plus r raised to the power negative n all over r. All over r. Okay, so the loan is 1,000. Interest rate is 1 plus 0.1. Number of years is 3 minus 3 all over 0.1. For me, I always say go and read table because this is present value interest factor of annuity. You can go and read your table so that you don't worry yourself. So 10% 3 years. Present value interest factor of annuity, 10% 3 years. So 10%, 10% 3 years, 2.4869. 2.4869. 2.4869. So we will have you pay 402 every year. 402.11. 402.11. 402.11. 402.11. Now we are going to draw an amortization schedule. So we have year, beginning balance, interest, installment, principal paid. Maybe let me use another sheet. Okay, I'm coming. So there's amortization schedule, a schedule. So year, beginning balance. I think 1G double N. So beginning balance, interest payment, installment, principal paid, and then ending balance. Okay, so let's see. Year one, the beginning balance on the loan was 1,000 cedis. Okay, and interest rate is what? 10%. Interest rate is 10%. So 10% on 1,000 is what? I think it's 100. 10% of 1,000 is 100. But every year we are paying installment of 402.11. Okay, we are paying installment of 402.1. So if you like the installment, you can write it down. I mean, for all the 3 years, it's the same. You can write them down for all the 3 years. It's the same. Now, let's watch something. Let's watch it carefully. Now, I got a loan of the beginning balance is 1,000. Interest payment on it. Interest payment on it is 100. So it will be 1,001. Okay. And I paid 402. So A plus B minus C. Like beginning balance plus interest minus the installment you paid. So it will be 1,000 plus 100 minus 402.11. It will be your ending balance, 697.89. That will be your ending balance. And it will come and start here, 697.89. So the ending balance will now become a beginning balance. So when you find 10% on this, it will be 69.79. So when you do 697.89 plus 69.79, that will be the amount that you'll be owing, A plus B. Then you subtract the installment. You subtract because you are paying the installment. So you add beginning balance to the interest, you subtract the installment, 402.11. Your ending balance should be no, 697.89 plus 69.79 minus 402.11. Your ending balance should be 365.57. So 365.57. We find 10% on this. That would be your interest. So that would be 36.56, 2 decimal places. So when you add these two, 365.57 plus 36.56, when you add the two, you get 402.13, so minus 402.11. Like you get approximately zero. You get approximately zero. It's because of the decimal points. So you see that by the end of the third year, you would have finished paying. Now you see that I've left the principal payment column blank. How do we find principal payment? Now remember, anytime, listen carefully, anytime you pay installment, it fully covers, anytime you pay installment, it fully covers the interest. Then it will cover part of the principal. So how do I get this principal paid column? How I get a principal paid column is that I would subtract the interest from the installment. The remainder will be the principal. So 402.11 minus 100, 302.11. That will be the principal. So 402 minus the 69, 69.79. Then 402.11 minus the 36.56. Okay. So this is what we are saying. Ending balance is equal to beginning balance plus interest minus installment. Interest payment is simply the interest rate times beginning balance. All right. Principal paid. The part of the principal you paid is your installment minus your interest payment. That's all. However, let me show you a very shorter way of getting the ending balance. If you do beginning balance, interest, installment, and principal paid, another way of getting ending balance is simply beginning balance minus principal paid. So when you subtract this from that one, you get the last one. When you subtract this from this, you get this. When you subtract this from this, you get this. That's another way of doing the ending balance. These are two ways, all right? So most likely, yes, most likely you may get an amortization, like in FM, in financial management questions, as for amortization schedule there, it's almost always there. The caution to all of us is that if you get this payment wrong, the installment, like your whole schedule will be wrong, obviously, as we can see. If you get the whole payment wrong, obviously, the whole schedule will be wrong. Now, what if the payments are not made yearly, but say semi-annually , or monthly or even quarterly. Some of us, we normally go for loan and pay monthly. The monthly one is the common one. What if so? Like, what if so? Now, if this is the situation, the formula will change a little. Why? Because if I'm paying, let's say, semi-annually, let's listen carefully. If I'm paying semi-annually, this 10% will now become 5%. Because 10% is for the year. So, and then the number of years will now become 6, because there are 6 semi-annuals in 3 years. There are 6 semi-annuals in what? 3 years. There are 6 semi-annuals in 3 years. There are 6 semi-annuals in 3 years. So when that happens, we just divide the R by the M. And then we multiply N by M. And M is the number of compounding periods. Number of compounding periods. M is the number of compounding periods. So if it is semi-annual, the thing will compound 2 times in the year. If it is monthly, it will compound 12. If it is quarterly, it will compound 4. If it is weekly, it will compound, how many weeks? 52, right? Yeah, 52. So all that we are saying is that whenever the thing is not yearly and it is whatever frequency, you divide the interest rate by the frequency and you multiply the N by the frequency. So here, this particular question we are solving, because it is semi-annual, it will be R over 2. Then it will be N times 2, because it's semi-annual. R over 2 and then N times 2. So now let's solve the question that was in the slide. I said I wanted to teach you something you can follow before we get to the slide one. So here, somebody's asking a question. Let me see. Can we just use the present value of annuity formula to calculate? Of course, that's what we are doing. Oh, yes, that's what we are doing. As in, no. Let me try and understand the person. As in, let me see what the person is trying to say. As in, the installment is this. No, this cannot be the installment. Look at what I wrote. Present value of ordinary annuity. The present amount you are receiving is the loan. Loan is the now amount. So the loan is actually this thing here. And we are looking for this payment. And so there's no way you can use the formula straightforward. You have to make the payment the subject and it becomes like this. Okay? You can't use it straightforward. If that's the question you're asking. Please, is that the question you're asking? Stephen, I would want you to comment. Is that the question you're asking? Yes, but is it clarified to you now? Is it clear to you now? Okay, all right. So let's come back to the one in your slides. The one in your slide says that suppose we have 1,000 3-year mortgage with an interest rate of 10% and semi-annual. Now, the word semi-annual makes the thing to compound twice in a year. If it is monthly, it will compound 12 times in a year. All right. So when it becomes like that, monthly, it means that wherever we see R, that's the implication. If the thing is compounding monthly, the implication is that, sorry, if it's compounding semi-annually, the implication is that wherever we see R, we divide by 2. Wherever we see N, we multiply by 2. Okay. So it means that our N now becomes 2 times 3, which is 6. And our R now becomes the original interest rate, I think it was 10%, right? Yeah, 10%. So it now becomes 10% divided by 2, which is what? 5%. So now the payment formula now becomes loan over 1 minus 1 plus R over M times the N, all over R over M. So it's like whenever you see the interest rate, you divide by the number of compounding periods. Whenever you see N, you multiply by a number. So the payment now becomes loan of 1,000 over 1 minus 1 plus. So if you divide R by 2, you get 5%, so 0.05. And if you multiply the years by 2, you get 6 over R over M is 0.05. So assuming this was 12, listen carefully. Assuming it was monthly, the N would have been 12. No, I think it was for 3 years. Yeah. So it will be 12 times 3, and that would be 36. Then the R will be 10% divided by 12. Have you seen that? Yes. So always pay attention to the question. How many times the thing is compounded? Good. If it was quarterly, N will be 4 times 3, like 4 quarters times the 3 years. Then the R will be 10% over 4. So always pay attention to the question. Hey, my negative, why do I always forget? Negative MN, thank you. Hey, negative, thank you. I don't know why I keep forgetting this. So the payment now becomes 1,000 over, when you punch everything here, okay, let me see, 5%. 5.0757. So it means the semi-annual payment will be this amount. The semi-annual payment will be this amount. The semi-annual payment will be this amount that we can see here. The semi-annual payment will be this amount. So the question can be anything. It can be monthly, it can be anything. Okay. Now, how do we draw the schedule? Now, since it's semi-annual, it means that we will have the time period will be 1 up to 6 because we have 6 semi-annuals in what? 2 years. We have 6 semi-annuals in 2 years. So we have 6 semi-annuals in 3 years. So we can't have 1, 2, 3. No, it has to be 1, 2, 3, 4, 5, 6. If it was monthly, remember it would have been 12 times 3. That would be what? 36. So you'd have 1, 2, 3, so up to 36. So if a question gives you monthly and it is like 3 years there, you have a lot of work to do. You do up to 1 up to 36. Now, let's look at our schedule. Beginning balance is 1,000. Now, the interest payment on the 1,000, remember, we have converted n to what? 6 because we said, somebody says, what of days? That would be, days will be 365. That would be too much. So if the question gives you 3 years and then they said that thing is compounding daily, you do 365 times 3 years. That would be something else. Now let's look at it. So if our n is 6, remember our r is no longer 10%. It is 10% over 2, which is what? 5%. So the interest payment, we will use 5% for the calculation, not 10%. Reason being that our r is now 5% because we divided it by 2. So always when you are doing the schedule, use the new n and use the new r. Don't use the original ones. Use the new n and the new r. Okay. And as for the schedule, you can do it. So 5% on 1,000, you get this. Then your installment payment is constant throughout. So it's the same throughout as we can see here. So the ending balance is beginning balance plus interest minus the payment, you get the ending balance. Then the ending balance will now come and start. You find 5% on it, you get the interest, you subtract the payment, you get the ending balance. This ending balance will now come and start. Find 5% on it, you add it, then you subtract the payment. So we've done this already when I used 3 years annually. So when you follow, you should be able to get it. How do we also get our principal paid? Our principal paid is what? The annual installment payment, the semi-annual installment payment minus the interest. You get the principal payment. Alternatively, if you have done the principal payment, if you have done it, your ending balance will simply be the beginning balance minus the principal. You get the ending direct. I have explained this to you already. So this is how, so after we close, go over this. You should be able to get the table that the question had. Go over, okay? I want you to go and try it on your own. Okay. The question said what are your semi-annual payments? We have done it. And then we should construct a schedule. We are done with the schedule. So we are done with this and that. The third question. What is your loan balance after 2 years? After 2 years, what is your loan balance? Now, after 2 years means that after 4 semi-annual payments, that's the meaning. After 2 years means after 4 semi-annual payments. So after this. If it was monthly, it would have been after 24 months. Okay, they want your balance after 2 years. So your balance after 2 years is technically balance after. So we are looking at the balance here, left to pay here. What is left here to pay? So your balance after 2 years simply means your balance after 4 semi-annuals. So after 4 semi-annuals, how much balance do you have to pay? So it means you have to pay this balance, like what is left with this? The payment, like these payments you have to make. These are the payments left for you to make. But you want to know how much is left right after the second year or right after the 4th semi-annual. Because 1, 2, 3, 4 here doesn't represent years, they represent semi-annuals. So you want to know how much is left right after the 4th semi-annual or the second year. So we have to find a way to bring these two payments back, like we have to value these two payments at the end of the 4th year. And remember, these two payments are what? Annuity, like they are two payments which are the same, annuity, okay? Good. So it means that we want to know value of the two payments left. We have to find their present value as at the end of the 4th payment. So how do we find the present value? Because there are two payments, so it's an annuity. So if you want to find the present value, it is the payment into bracket 1 minus 1 plus r raised to the power negative n all over r. So the payment left was 197.017 into bracket 1 minus, remember we are using an interest rate of 5% because we divided it by 2. So 1 plus 0.05 raised to minus 2 because there are two payments all over 0.05. So when you punch this, you get something like 197.017 times 1.8594. You get 366.33, like the answer they have. Now you realize that when you have the slides and you go through the answers, the formulas, the formulas I use are a little bit different, but you get the same answer. I like my formulas because it makes it easier for you to read from the table. All right. So don't worry, when you go through the slides and the formulas are different, don't worry. You get the same answer at the end. And the exams, any of the formulas is correct. Like for instance, instead of writing instead of saying Solomon, I'm coming. Instead of saying amount into bracket 1 minus 1 plus r raised to the power minus n over r. Some books would rather bring the r here, so they will say amount over r times 1 minus blah, blah, blah. Like that's what they are doing here. But it's the same thing, like as what I gave you, so don't worry. Okay. Yeah, so what the person is just saying that, and even Richard also tested, like Richard has also said it, Richard Kwabena. So if you want to know the balance that is left for us to pay after, you can just read the ending balance like this. It's correct, there's nothing wrong. Just that your slice wanted you, that the slice says compute it. But for me, if you read it directly, I don't have a problem because you are just being smart. Like for instance, the question was like, what is the balance left after the first year or after the 2 semi-annuals? What is left? It was 6, 6, 8, 9. You don't even need to compute. Okay, it's correct. That's okay. So you can do that. Okay. And then, how much interest would you have paid after 2 years? How much interest would you have paid after 2 years? Okay. How much interest would you have paid after 2 years? So you can also, as you are saying, you can just, so instead of using this long formula, if you want to know the interest you'd have paid, you would have paid after 2 years. So you can just add here, this interest. So 50 plus 42.65 plus 34.93 plus 26.83. Okay, so you can just get it straightforward. So when you add this interest, like this interest, you get the 154. You can get it straightforward. Or you can use the formula they've done. The total payment you would have made, like the total payment you make, the total payment means that you add everything here. That's the total payment. You add everything. You get 788 minus into bracket the loan itself minus the loan balance. But I think that is a long approach. You can just add, you can just from the table, you can just add all the interest payments and you are done. Okay. So I mean that's a very smart way of doing it so that you don't really worry yourself with that. So that's a very smart way. So in a typical amortization schedule question, these are the things that they will ask you to do. Okay, these are the things that they will ask you to do. All right. Now I can see many people are even leaving the platform. I don't know for whatever reason. So we will pause here.